Do. Welcome to Chav's channel, where calculus class is back in session.
What's up? Calculus class is back in session. Hand of applause for Revia. Way to go. Pretty awesome. That was pretty cool. All right, guys, welcome back. I hope you guys are ready to go. So let's go. All right. The function f is graphed below in the interval gives the number of values c between 0 and 10, which satisfy the conclusion of the mean value theorem. All right, so if you had a straight edge or a ruler and you connect these endpoints together, you get this line. Okay, it's not super awesome, but that's fine, guys. So what I want to know in this one is how often do I have tangents that are going to be parallel to that line? So it looks like I have one right about there, guys. It looks like that tangent's parallel. And then if you keep following it right about here, and it looks like you have another tangent that's parallel. So that is 2. So the answer is 2. Does that make sense, guys? Now remember what the mean value theorem is how often is my instantaneous rate of change equal to my average rate of change. So this blue line, the slope of that blue line is your average rate of change, and the slope of those red lines is your instantaneous rate of change. So that's all it means, guys. So here's your average, and this is your instantaneous, guys. Let's keep going. Question 2. Determine if Rolle's theorem applies to the function x cubed minus 9x between 0 and 3. If so, find out the number c on the interval that satisfies the theorem. All right, Rolle's theorem is a special case of MVT. It just wants to know is my average rate of change 0? So that's what they want to know. So first, let's find out. So I'm going to write f of 3 minus f of 0 over 3 minus 0. So I need to see if I get a average rate of change of 0, guys. So if I plug in a 3 there, let's see, 3 cubed is 27, 9 times 3 is 27, 27 minus 27 is 0, and if I plug in a 0, I get a 0 again. So yeah, so I do get average rate of change should be 0, so this one is out. Rolle's theorem does not apply. It does apply, so it's out. So I'm going to take my derivative, so here we go. F prime of x is 3x squared minus 9, and I'm going to equal that sucker to 0. And now you're just going to solve for x. So they want to know at what value of x, or c in this case, c just means a specific x value, at what x value is my instantaneous rate of change, my tangent line, parallel to my secant line between 0 and 3. That's all they want. So here we go, guys. So 3x squared equals 9, divide by 3, so you get x squared equals 3, and then take the square root, you get x equals plus minus 3, and they want you to circle the plus and minus 3, but remember, the interval, that's the square root, by the way, the interval is between 0 and 3, so you just take the positive one, guys. All right, let's go to the next one. Determine if the function 4 square root of 25 minus x squared satisfies the mean value term between 0 and 5. Yes, you're defined everywhere, and you can, so yeah, mean value theorem applies because for the mean value theorem to apply, you got to be differentiable in your interval, and you are. So you're good, and you're continuous on your interval as well. So let's find out what the average rate of change is. So I'm going to plug in a 5, so I'm doing this, f of 5 minus f of 0 over 5 minus 0. If I plug in a 5 there, 5 squared is 25, 25 minus 25 is 0, and you get 0. Minus, if I plug in a 0, I get 25 minus 0, which is 25. The square root of 25 is 5, and 5 times 4 is 20, divided by 5 minus 0, and I get a negative 4. So that's my average rate of change. So now I'm going to take a derivative. So before I do that, oh, that wasn't a fart, guys. That was the chair. Before I take a derivative, I'm going to rewrite this. 4 parentheses 25 minus x squared to the half. And now I'm getting ready to take a derivative of this. So here we go. F prime of x equals half of 4 is 2. 25 minus x squared to the negative half times the negative 2x. So now I'm going to rewrite this, and let's see. I'm going to write it as negative 4x over the square root of 25 minus x squared. So here's my derivative, and I'm going to equal that to negative 4. So here we go. Negative 4x over square root of 25 minus x squared equals negative 4. So multiply both sides. So now I got negative 4x equals negative 4 square root of 25 minus x squared. The negative 4's go away. So now I'm going to square both sides. So when you do that, you get x squared equals 25 minus x squared. I'm going to move the 25. I'm going to move the x squared to the right. So now I have 2x squared equals 25. Divide by 2. X squared equals 25 over 2. Take the square root, and you get x equals plus minus 5 over square root of 2. So if you rationalize this, you get 5 square root of 2 over 2. So now I got to choose values for this, guys. And because my interval is 0 to 5, I'm going to choose the positive one. Cool? Cool. All right, let's keep going. This graph here is f prime. The graph of, oh no, it's f of x, sorry. This graph here is f. So they want to know when f prime is 0. Well, f prime means my tangent slope, and my tangent slope is 0 only there. So at x equals 0, and that's it. Let's go to the next one. All right, guys, here we go. So I need f prime to be positive. So I'm going to take a derivative. F prime of x is equal to 7 times 4 is 28. So 28x cubed plus 12x squared. I'm going to factor out, let's see, I'm going to factor out a 4x squared. And when I do that, I'm going to get 7x plus 3 equals 0. And I get two critical numbers, 0 and I get negative 3/7. So here's my number line. I'm going to call that f prime. And I'm going to go negative 3/7. And I'm going to go 0. So if I choose negative 1, this guy's always positive, so don't worry about that guy. If I choose negative 1, negative 7 plus 3 is a negative, so negative. If I choose like a negative 2/7, I'm going to get negative 2 plus 3, which is positive. And if I choose 1, I get another positive. So where am I increasing? I'm increasing between negative 3/7 and 0, and then union 0 to infinity. So here we go. All right, let's continue. Oh, by the way, a case could probably be made, guys, on this one that you're increasing from negative 3/7 to infinity. But I don't think they put that option in here. So don't worry about it for now. Here we go. Find the intervals on which this is increasing. Before we start, guys, there are no vertical asymptotes. So no VAs, no vertical asymptotes. So let's just take a derivative. F prime of x, bottom, x squared plus 49 times the root of the top minus top times the root of the bottom all over bottom squared. So I don't care about the denominator in this case because the denominator will never be 0. Plus I don't have any vertical asymptotes. So here we go. So all I care about is the numerator. I'm going to factor out a 6, guys, because I see a 6 here and a 6 there. So I see x squared plus 49 minus 2x squared. So if I just take this guy here, you get negative x squared plus 49. And if I equal that to 0, you get that x equals plus or minus 7. So again, I'm going to do a little number line. I'm going to call that f prime. And I'm going to go negative 7. I'm going to go 7. And I'm just going to put numbers in there, guys. I'm putting numbers into this guy. If I choose 0, I get a positive. If I choose a number larger than negative 7, like negative 10, I get a negative. And if I put 10, I get a negative. So, by the way, why didn't I take the denominator into account? Because it's always being squared, so it's always going to be positive. So where am I increasing? Between negative 7 and 7. All right, on this one, you do have vertical asymptotes, guys. So before you even start, realize you have vertical asymptotes. So 9x squared minus 4 equals 0. 9x squared equals 4. X squared equals 4/9. And then square root. X equals 2/3, plus minus. So these are VAs. Now that you know that those are vertical asymptotes, now I'm ready to take a derivative. So here we go. F prime of x is equal to bottom, 9x squared minus 4 times the root of the top, 18x minus top, 9x squared plus 4 times the root of the bottom, 18x again, all over, oh, sorry guys, there's an ant here. All right, all over bottom squared, 9x squared minus 4 squared. All right, I'm going to factor out an 18x again. You already know your vertical asymptotes and the denominator is always squared, so I'm just messing with the numerator here, guys. So I'm going to factor out an 18x, and if you factor out an 18x, you're going to get 9x squared minus 4 minus 9x squared minus 4 when you distribute the negative like that. So then, let's see, these 9x squares cancel out, and you just get negative 8. So 18x, negative 8, and then the bottom you still have the 9x squared minus 4 squared. That's what you have, that's f prime. All right, so you have one critical number, just when x is 0. So here's my number line. I'm going to call this f prime. I'm going to put 0, and I'm going to put my vertical asymptotes, negative 2/3 and 2/3. I'm going to choose a number to the left of negative 2/3, like negative 1. Negative times a negative is a positive, so I'll put positive. I'm going to choose a number in between, so like negative 1/3. I'm going to get a positive again. I'm going to choose 1/3. I'm going to get a negative. I'm going to choose like 1, and I'm going to get a negative because of this negative right here, guys. So there it is. Where am I decreasing? 0 to 2/3 and 2/3 to infinity. This time you do need the 2/3, and this time you cannot say 0 to infinity because the 2/3 is a vertical asymptote, and you do not cross vertical asymptotes. All right, let's keep going. So again, we're going to find the derivative of this. It looks like it's just a good old-fashioned product rule, guys, to get your critical numbers. So I'm going to go first, 4x squared times root of the second. I'm going to go 2, 6 plus x times 1, and then plus second, 6 plus x squared times root of the first, and I'm going to say that's 8x. And there it is. So I'm going to go ahead and I guess I can simplify this. 2 times 4 is 8x squared. So 8x squared, 6 plus x, plus 8x, 6 plus x. So what I can factor out, guys, is an 8x and a 6 plus x. This is actually squared there, sorry. So here we go. I'm factoring out an 8x, and when I do that, I'm factoring out an 8x and I'm factoring out a 6 plus x. So 8x, 6 plus x, close it, open. I'm going to have 1x plus 6 plus x. So 8x, 6 plus x, 2x plus 6. I'm going to equal that to 0, so you get three numbers, 0, negative 6, and let's see, negative 3. So here's my number line. I'm going to call that f prime. I'm going to put negative 6. I'm going to put negative 3. I'm going to put 0. So I'm going to choose a number like negative 10. So negative 10, negative, 2 times negative 10, negative. So negative, 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 that's going to be negative. I'm going to choose a number like a negative 5 or negative 4, negative 5. That's going to be negative. That's going to be positive. That's going to be negative. Negative times a negative is a positive. I'm going to choose a number like negative 1. Negative, positive, positive. That's going to be negative. I'm going to choose a number like 1. Positive, 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 positive. So where am I decreasing? Negative infinity to negative 6 and negative 3 to 0. All right, let's keep going. Find the intervals on which this is increasing. So let's take a derivative. F prime of x is equal to 8 plus a negative 8 sine x. So the derivative of cosine is a negative sign. Equal that to 0. So let's see, negative 8 sine x equals negative 8. So sine x equals 1. So that means that x equals pi over 2. So now that I know that x is pi over 2, here's my critical line. Actually, it starts at 0 and ends at 2 pi because it's a closed interval. And I'm going to put a pi over 2. All right. So if I plug in let's see, a number between 0 and pi over 2, so I'm thinking like pi over 4. If I plug in a pi over 4 in here, I'm going to get 8 minus 8 square root of 2 over 2, 8 minus 4 square root of 2, and that is a larger number. 4 square root of 2 is smaller than 8, so this will be a positive number, so I see plus. And if I have a number bigger than pi over 2, like pi, so I'm going to have 8 minus 0. It's still going to be a larger number, so it's still going to be positive. You know what? I should have stopped right here, guys. Check it out right there. If you factor out the 8, you're going to have 1 minus sine x. And look, guys, that's always larger or equal to 0. Always. I mean, I guess if sine x is pi over 2, then you're going to equal 0. But you're always increasing. You're never negative. That's what I'm trying to say. So I should have stopped right there, guys. My apologies. You're always increasing. 0 to 2 pi. And again, you could have made a case for stopping at 2 pi, 0 to pi over 2, and then pi over 2 to 2 pi. But they didn't. So you're always increasing, guys. It's always positive. All right, so here we go. Last one. I think it's the last one. Yeah. So find the intervals in which this expression is decreasing. So let's take a derivative. F prime of x is equal to, before I do that, guys, that is the same thing as 4 cosine x squared. So here we go. 4 times 2 is 8 cosine x, and the derivative of cosine x is a negative sine x. So there it is. Negative 8 cosine x sine x. I'm going to get critical numbers. When does that equal 0? Well, that equals 0 when x equals 0 for sine x, for cosine x when x equals pi over 2, and then back for sine x when x equals pi. Now notice the 0 and pi are endpoints, so that means we just got to test pi over 2. So here's my railroad track, 0, pi, and then pi over 2. I'm going to call this f prime. If I plug in pi over 4, cosine and sine are both positive, but I got a negative here, so I'm going to say this is negative. If I plug in a number that's bigger than pi over 2, like 3 pi over 4, cosine of 3 pi over 4 is a negative square root of 2 over 2, but sine of 3 pi over 4 is a positive. So negative times a positive is a positive. So there it is. I want to know decreases. It decreases between 0 and pi over 2. So there it is, guys. All right, I hope you guys enjoyed this video. Give me a thumbs up, please, especially if you enjoyed Revia's intro. And I hope you guys are happy. All right, talk to you guys later, guys. Bye.